that's waiting. I'm going to see if this worked. So here's the thrust puck. It should stick to this thing. All right, that worked. And here's the thrust puck here. It should stick to this thing. There, it worked. Okay. And as I suspected, well, I can't pull it out. So I didn't need to magnetize the next section, but just in case, it's probably a good idea. So this section should stick to this section. Yeah. Yes, I can pull it out. I think when I put the spline in here, even though it's magnetized, I'm just going to glue, even though I have a magnet here instead of locator pins, I'm just going to, because I'm going to put the spline in here, so it's going to be super rigid. I'm just going to go ahead and glue these even though they have magnets in them. Then I don't have to worry about it. Because it is possible to take this out using your fingers. I'll take this out using your fingers. So I didn't need to get access to this side of it. So too late to take the magnets out of here, unfortunately. If I'd been more patient, I would have just done this and tested it before I did this. So I was impatient. That's all right. Okay, so I'm happy that was my strategy for making sure magnets line up is working. So hey, pip, hooray. We can try another thing. So this is done now. We can see if this sticks to this now. Yeah. So that's how we're going to stack it up on the tower, on the base here and on the tower, is that this has to stick to this so that the Starship sticks on top of the booster. So that's another way. Hooray. All right, so we're making progress. I think we can put these magnets in now. Let's do that. Let those dry. So again, we're going to use our same technique. I'm just going to show the start of it here. We're going to pop a magnet onto here. And then we're going to take it off with the pliers. Oops. It's in there. Take it off with the pliers. Put your thumb up against the side that needs to go down inside this pocket. Put some glue in there. Use your forefinger, press it in, and slide it over into the pocket, and then use your plastic tool to seat it. All right. So I'll do the other two, and then we'll keep assembling the rocket. We may start from the bottom and work our way up to here at this point. All right. So one thing we've been forgetting to do is glue the spline as it goes. So that's a mistake, but you should put these segments together. You should put the spline in. Actually, yeah, we could have put it in the beginning anyway. We didn't do that, so we're going to put some glue on it now as we insert it. And then as it goes through each of these segments, it'll glue itself to it. So we're going to put some on the bottom here, so when it gets seats down in there, it's going to have some glue on it. And we'll put some glue on these sides to get it started. Probably way too much glue, but anyway. Alright, then we'll put some glue as it goes. Some drops of glue here on each side. You put some more holding power. I'm going to move fairly quickly because it will dry as it goes, so we got to get it all the way in there before we're done here. One more set. All right, now it's seated in there. We're going to press on it. Okay. So that's that part of the booster. And then the next segment, we're still going from the top because I started that way. I'm going to keep going. So next segment, we're going to put this piece on. We need to line up all these pipes. So this side has 3 pipes, and this side only has 2 pipes. So watch out for that. And this is the start of where those flares are too. So we're going to put locator pins on this. We're going to put them all around, and also in the spline, because the spline, in his design, there's magnets in here. And I'm looking to see, it looks like these are only set up for magnets, so that's annoying. So I don't think locator pins are going to work here. Oh, maybe they will. Let's see. They're not tapered. The holes are not tapered like okay. The locator pins are. The holes are deep enough for locator pins to work, but the bottoms are not tapered. The bottoms in this segment are tapered. The bottoms in this hole, in this socket on this segment are tapered. They're not tapered here, but they're still deep enough for the locator pins to work. So, all right. So we need. We need locator pins, 6 locator pins. So just gonna put glue everywhere. That's a little quicker. It's enough time to get them in there before it dries, so they don't drop too many of them. I should have put these ones in first before I put in the spline. I should put these in, obviously, so you can do that. Actually, it's not that hard if I do it this way. Okay, those are in. I need 3 for the spline. Those are easy to put in. Alright, I'm just going to press all those down, make sure they're seated. Okay, so that's that. Now this piece is going to go on here. And then after we get this piece on, we'll put the spline in, and we'll start putting the spline in as we go this time. Alright, so we got the 3 pipes on this side. Let's see. Wait a minute. 3 pipes on this side, right? There we go. That's correct, okay. Alright, so I'm going to put some extra glue on these things. We'll have to get the spline in there pretty quickly so that glue can work with that. And we're going to glue this thing. Put some glue in these sockets and around the edges a little bit. Oops. Over there. Alright, then we got the 3 pipes on this side. It's going to go this way. Right, we're going to push on this. Not too long because we want to get the spline in there. So this end of the spline is going to go into that other thing, the other end of the other spline. So putting glue and some other glue. And some glue along here because that side's going to be hidden now. Alright. The orientation of this doesn't matter. It's symmetric. So. Alright, so that's all solid. Now at this point we're going to start putting glue in here and let it wick down around the spline. So that's that. Alright, so now while that's drying we can put the next 3 locator pins in. Here, pretty tall. The booster is much taller. It's about twice as tall as the Starship. So maybe exactly twice as tall. Not sure. All right, so we'll put the locator pins in. Let those start drying. I have to use my pliers to get those in. There, that worked pretty well. Pliers are smaller than my fingers, so this is a good technique. Again, just be glad we're not working with magnets. Alright, that's another one. Alright, so we got that in. Now let's find the next segment to go. So this segment is this one here now. It's got the little flanges out, so this has to go in this direction. You can see this is asymmetric now, so now we can tell which direction it goes. So it's got to go this way. And we can double check. So there's 2 pipes here. And on this side, there's a whole bunch of pipes, so that's correct. All right, so this is going to slide over here. So before we do that, we're going to put some glue on the spline so it gets glued in. It's just going to use wicking. It's going to wick in there. I'm going to put some glue on these little star points sticking out too, because we want those to glue. And then we're going to put some glue in these sockets over here. 3 sockets and some around the perimeter. You can probably tell I don't want this to ever come apart, so that's the whole idea of gluing it. I mean, these 2 segments, I connected these with magnets. Yeah, these are the ones that go with magnets. No, actually, it's not that one. It's the next one. It goes up here. That's right. Yeah, this magnetizing, to me, it's not that solid. I mean, it moves around, right? So I don't like that. Okay, anyway. we got this done. Now this is the segment that goes on now. And again, this is asymmetric, so it should be easy to line up. Yeah, these go this way. This one we're just going to glue. Unfortunately, we don't have the locator pins because we already put magnets in there. But there's plenty of glue around here that should be able to hold it. A little bit higher. It's almost the full height now. So that's the right direction. Okay, so now we're going to put glue on these splines. There's nothing for this to attach to because there's a hole in the other one. So I'm going to put glue all around. Now, one good thing is the magnets will hold it in place. I'm going to put glue all around this one too. And put some glue in here just to get those splines if we can. Alright, now we're going to hold this down. I want this to be really, there's no locator pins, so we want this to be really solid. So I'm going to sit here for a minute and hold this, and then I'll come back and we'll finish it up. Alright, there's the booster. Yeah, this is a little bit, I'm going to put it on here for now. So there's a little depression here. So that actually, if you don't flip it over, then remember these center engines stick out with this depression here, so it'll fit on there. So it's going to be more secure flipped over. We'll show that in a minute. Now I'm going to put the hot staging ring on, which goes this way. Uh-oh. Looks like I messed up one of the magnets. Dang it. Oh well, I messed up the polarity of one of the magnets, so it's not lining up. Berg! Which one did I mess up? Let's see. So these are all correct. The hot staging ring is messed up. Yeah, this one is backwards. Alright, so I'll see if I can get this one out. I don't think so. I'll have to reprint this hot staging ring. Alright, we need to reprint the hot staging ring because we messed up some of the magnets. So that gives an opportunity to make it a better quality print. This is what the original print looked like. I'll show it to you over here. So these columns here didn't come out very well because they're too thin. Not enough material here to make it look good, so they were all kind of wiggly, so that wasn't that great. I mean, for me, it didn't matter that much, but so we're going to try. So the problem I think is that I'm using this 0.48 millimeter extrusion width. So what I've done on other projects, I've changed this to 0.4, which is the the actual nozzle diameter. And if we do that, then some of them have more material, but the other ones are still thin. So I'm going to try something I haven't tried before. I'm going to try changing this to 0.3. I don't know if it'll work. Presumably the slicer knows what it's, or the printer can do that. So now all the columns have much more, have at least a a full perimeter with some space inside. What if we do 0.2? I don't know if I want to press my luck here, but I do have a 0.2 millimeter nozzle, but I don't really want to do that. I don't want to put that on just for this one thing. It's got infill. Okay, you know what? We're just going to go for it and put in try 0.2. And it takes 2 hours to print, which is okay. And then, not sure, I'm going to try to put magnets in again. I just glue it and figure out some way. I mean, I probably have to put a magnet in here to get it to stick properly. Hopefully I'll do it right this time. And then I'm still going to glue it though, because I don't need an extra thing to come off. Now, in Flight 4, they did eject the hot staging ring because it was extra weight, so they thought they'd have a better chance of landing the booster in the ocean vertically if they got rid of it. But eventually, it's going to be part of the booster. So I don't want to have it as a separate part. It's just confusing. So, all right. So we'll go ahead and print this. 2 hours. That's a good. I have time for that. And then we'll see how it turns out with a 0.2 millimeter extrusion width. Let's see if that actually works. Doesn't seem. I'm not sure how that's. I guess. Hopefully the printer can do that. We'll find out. All right, here's the replacement hot staging ring. So if you look at the surface, it looks really shiny. And it looks like putting in 0.2 millimeters in the slicer for the extrusion width actually worked. Look at the edges. This is the old one. That's just one single column of 0.4 millimeter extrusion, and this is the 0.2 millimeter. So it took twice as long. There's a little bit of stringing in there, but the quality of this one, the new one, the 0.2 millimeter one, is obviously higher. If you look at the surface here, this is the old one. You can see the layers. You can see the extrusion lines here. Here they're nicely melded together in a nice shiny surface. So even though this was a mess up, it's actually giving me a new tool I can use in the future. If I want some slightly higher resolution prints without having to go to a 0.2 millimeter nozzle, I can do it with the 0.4, and the slicer and the printer can handle that. So that's so out of adversity, a new thing for the toolbox. So I'm counting that a win. All right, so now we got to put these magnets in without messing up this time. So we're going to start with the ones for the bottom, like we did last time. We're going to take this support material off of here. So this actually looks better over here, but this is going to be covered up. It's going to be in the glued section, so we don't care. In any case, we want to do the same thing we did last time. We'll take these flaps off. And we want to put magnets on here and then take them off and then transfer them carefully to here in the opposite direction. So I already showed that once. I'm not going to show it again. And then once this is set, then I'll show you how we're going to attach this to the top of the booster without messing up this time. So I have a new idea for that. As again, remember, we couldn't use we can't use locator pin. We could make our own locator pins, or we could file the ones down that he made. But I don't want to do. I already have magnets in here, so I'm stuck with magnets here. But I have a new idea how to get it in there without messing up this time. So we'll see that. All right, we're finally ready to finish this spaceship off. So we're going to see if we got these magnets correct. We did. That's a nice, good snap connection to the booster from the. I put another magnet in there. I wonder if it would fit even stronger there. How strong is it? I think there's enough room for one more magnet there. I need to have 3 magnets stacked up. First, we'll just do it the way they said. So this is the one that was messed up. So we'll get rid of that one. Now, the trick I told you about earlier that I was going to use to put this on the... Alright, so we got magnets in here. We don't have any magnets in here yet because I was worried about messing them up. What we're going to do is we're going to just glue the magnets on here. They'll all be in the right direction. Then let's use those as little locator pins to glue into here. So that was my trick. So we're going to put some glue on these magnets. Put slug of glue on there. And then, yeah, we're going to take it off of here. We don't want to, no reason to get the Starship involved. And we're going to take a magnet, 3 magnets off here, one at a time. Snap them onto here, so they're already gluing themselves from the pressure of the magnet, one to the other. It's hard to get just one magnet off of these stacks. There. Alright, there's our 3 magnets. Now, I'm going to put our extra glue along here. And it's on top of the magnets. I'm going to put a little bit of glue on this side. Put some glue in these holes. And, like I said earlier, this is an add-on to the Starship. So the orientation of this doesn't matter. So. There. But it is going to become a permanent part of the booster, so I'm not interested in removing it when I'm doing demonstrations. So. Alright, that's that. Now, to finish off the booster, we're going to put in the grid fins. We haven't done anything with those yet. So there's 4 ports for grid fins on the side here. They're not symmetric. Although I just heard from an interview with Elon Musk that according to their calculations, only 3 grid fins are really required. And they might be able to get rid of 2 grid fins with basically no margin of error, they said. So there may be fewer grid fins in the future, but that's fine. That doesn't really matter for what I'm trying to do. So just want to show how the grid fins work. So it's coming back in for a landing, and the grid fins can adjust its orientation along with the gimbaling rockets at the bottom. All right, so there's our Starship and booster. The whole thing in. So now we can snap this on top. You see the whole thing now. I have it on super wide on my GoPro here. All right, there's our rocket. I'm going to put it on the stand. See how well it stands up on its own. So as you saw, I've got the bottom of it reversed. Yeah, we get the whole thing in. All right, cool. Bottom of it is reversed to make a little post here that the rocket, so it's less likely to tip over. There's our rocket all set for our next outreach event. All right, now we got to work on the. Oh, I got to put the fins on. So it wasn't quite ready yet. The fin goes on this side. Careful. All right. Now it's our full Starship and booster. All right, ready for our next outreach event. Hooray. All right, one more critique of his design is the grid fins. So grid fins insert, but they're really loose. They just kind of come out. So that's going to be a problem. We still want to show them, you know, I want to be able to demonstrate that they rotate, and that's how it controls re-entry. I think that's important. But we need to do something about this. So there are ways to make things like this. I've done it for some of my projects. They work like Lego pieces. This piece has a split in it and a bulge at the end, and then when you push it in, the split compresses, and then when it gets inside, there's a bulge inside, and then it snaps in, and then it'll rotate, and it won't come out without some extra force. So he didn't do that. But so I could, you know, redesign this part to have a split in it and a bulge. Even though there's not a bulge in here, it would still act with enough friction probably to work. But my short-term solution is to use silicone tape. This is used to, here's a reel of it. It's used to fix leaking hoses and things like that. So it sticks to itself really well. It provides some friction. I tried Teflon tape, which is used for connecting pipes together on the threads, but that's too slippery. That's not what we want. So it needs friction. So this side I already put some on, and it turns with more friction, and it doesn't come out. So at least without a lot of force. So my trick was cut a piece that maybe a little shorter than this. So this is about a little over ½ inch long. So what's that? 15 millimeters maybe. All right, then I take the piece and I drape it over the axle of this part and catch it on both sides with my fingers, and I stuff it in there so that it gets trapped inside. So this is very stretchy, so you stretch it around. You got to capture it. It's very stretchy, and then shove it in. And now it's providing a lot of friction. So some is sticking out, so I'll get some scissors and snip that off, but some sharper scissors than this. And then I'll just dupe the other ones too. So I'm already concerned about the flaps coming off when I transport it, because these just pretty much come off. So I'm going to put these in a bag so I don't lose them in the box. And then when I get there and set everything up, I'll snap them back on for the display. But they're easily get lost. So because it doesn't use a hinge, which again I commend him on his design. I think it's a good solution to the flap problem. But I think he fell down on these things. So if you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming,
and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.